Alrighty, so today we're going to go ahead and talk about some more derivative rules and some more trig rules. So when I'm talking about more derivative trig rules, I'm talking about the ones we don't have yet. So we've seen sine and cosine, but we haven't seen anything else yet. So we're going to have the derivative of tangent. And the derivative of tangent is secant squared of x. We also have the derivative of secant, which is equal to secant x tangent x. Next, we have the derivative of cotangent, and that is negative cosecant squared. And the last one is the derivative of cosecant, which is negative cosecant, I always miss that second C. So it's cosecant x cotangent x. So the best way that I think about these four is tangent and cotangent kind of go together. So they're the opposites squared. Secant and cosecant start with themselves and then their buddies come with. The hardest part is remembering these ones have the negative sign. If you guys can come up with a different way to remember them, awesome, but that's all I've got, is that these two are built on each other because cotangent is made from tangent, and that they're both squared. They're buddies squared. And secant and cosecant are made out of each other. Okay, so let's go ahead and do some quick derivatives. So we're going to take the derivative of the following. So the derivative of x is 1. The derivative of tangent is secant squared. So my answer is 1 minus secant squared. Next one I have x secant x, which means I need to do product rule. So I have the first times the derivative of the second plus the second times the derivative of the first. So in this case, I have x secant x tangent x plus secant of x. I can't combine anything between those two different terms. So I'm just going to go ahead and leave it. This third one needs the quotient rule. So I'm going to do an arrow and do it over here. So I have low, d high, which is negative cosecant x cotangent x, minus high, d low, all over low squared. Alright, same idea, we're just going to multiply that x through, so negative x cosecant x cotangent x minus cosecant x all over x squared. Alright, this next one. We're going to have to do a couple things, or we really don't have to do much with it. I should have put this together with the other page. Whatever. First, we have to rewrite that x, the cube root of x, so that's x to the 1/3, plus 8 secant x Derivative of 1/3. X to the 1/3, excuse me, is 1/3. X to the negative 2/3. Derivative of secant is secant x tangent x, so my sign doesn't change, so plus 8 secant x tangent x. This is the only thing with the negative exponent, so that's the only thing that's going to be a fraction. So it's going to be 1 over 3x to the 2/3 plus 8 secant x tangent x. Alright, so this first one has to do with product rule because I have things being multiplied together. So I have the first times the derivative of the second, which is negative cosecant squared, plus the second times the derivative of the first. Go ahead and multiply those two, so I have negative 7x cubed cosecant squared x plus 21x squared cotangent of x. And that's just my answer on that one. This next one, I don't need any of my rules. I can just take the derivative of the stuff. So the derivative of 8x is 8. The derivative of cosecant is cosecant cotangent. But it's negative, so it's negative cosecant x cotangent x. This third one's going to take up a little bit of room, so I'm going to kind of start it right here. Just because I don't like getting too close to that side of my computer. It makes things pull up. I know you guys can't see it on the videos, but I can see it and then I can't finish the problem and then it gets difficult. So the derivative of cosecant we just did was negative cosecant cotangent, so my sign changes, so it's going to be positive. Derivative of sine is cosine. So my answer is cosecant x cotangent x minus cosine of x. Alright, we got another quotient rule. So we have low, d high, minus high, d low, all over low squared. So we're going to multiply that stuff together. So I have negative x cosecant squared x minus cotangent x all over x squared. No, I can't cancel anything out with those x's. If I wanted to cancel, I would need an x in front of this cotangent somewhere, or some variation of x, so either x to the third or x to the fourth, or just some power, and I don't have one, so I can't cancel anything out here. So that's just my answer. Whew. Excuse me, guys. Alright, we're going to have to use product rule on this one, so let's rewrite that first part. It's x to the 1/2. So I have the first times the derivative of the second plus the second times the derivative of the first, which again, we've seen this one specifically quite often. So we should be getting used to seeing it. Yay! Alright, so we get x to the 1/2. That's not a good exponent. Let me do that again. We have x to the 1/2 secant x tangent x plus, remember I have whole times piece. Whole times piece. So this gets multiplied to whatever's on top. So secant times 1 is just secant all over 2x, the 1/2. That's all I got. Okay, so remember how I said that we're going to do more than just the first derivative? Here it is. So it's going to be written in several different ways. So we're going to see all 4 of these in several different ways. The first way that I can see it, we've seen our x prime, or f of x prime, so now we can have y prime. We have it as f prime of x. We always start our, oh, it does not look like y. We always start our notes with this one. dy of dx, saying the derivative of. We've also seen this. And the last way is like this. So that's the first derivative. That's all the different symbols to represent the first derivative. So let's take a look at the second. So we have y double prime, f double prime of x, d squared y over dx squared, d squared over dx squared of f of x, dx squared of y. So essentially what we've done between the first derivative and the second derivative is either added 2 marks, went from 1 to 2, or we've added squared terms. So let's talk about the third term. Here's the third degree. Third derivative, you know, that too. We have y triple prime, f triple prime, d cubed y over dx cubed. We have d cubed over dx cubed of f of x. And we have dx cubed of y. Now, the only difference here for the fourth is that we can't really put 4 tick marks because after a while that gets quite annoying. So we have y4 in a set of parentheses. We have f4 in parentheses of f of x. We have d to the 4th y over dx to the 4th. We have d to the 4th over dx to the 4th of f of x. And lastly, we have dx to the 4th of y. We typically won't go over doing more of this. It might ask you for the 5th one, but it'll give you the 3rd or it'll give you the 4th. So after 4, we will see everything in this last manner. So it'll be whatever that number is. So say we're looking for the 6th root, or the 6th root. The 6th derivative, if we're looking for the 6th derivative, we'll have a 6 there in that set of parentheses, or 7, or whatever derivative we're looking for. And it'll specifically tell you, or it'll give it to you, usually in this manner, or this manner in the book. Okay, so we're going to go ahead and find the 4th roots. I keep saying roots, I'm sorry. We're going to find the 4th derivative of the following polynomial. So first things first, if you do not have a calculator, you need to pause your video and go get one. Okay, good. We have all of our calculators. So my first derivative is just normal, so I'm going to take my 2 and multiply it with my 6, and I get 12. Then I'm going to take my 8 with my 3 and multiply and get 24. X to the 7th. Now, between going from first derivative to second derivative, the best thing to do is to simplify as much as possible before moving on. I don't have any simplification I need to do in this specific problem. If I did, I would, but because I don't, I'm going to just keep going. But this would be the time now, before going on to the next one, to simplify anything. So now we're going to take the second derivative of the blue term. So I have 5 times 12, which gives me 60, x to the 4th. And 24 times 7 gives me 168, x to the 6th. Again, simplifying when need be, combining like terms, all that good stuff. I don't have anything, so I don't need to do anything. So now we're going to take the third derivative based on what's in green. So 60 times 4 gives me 240, x cubed. 168 times 6 gives me 1008, x to the 5th. And now, finally, to do the fourth, I have 3 times 240, which gives me 720, x squared, plus 5040, x to the 4th. Again, simplifying between all of those different terms. Okay, it's your homework.